Hi guys, today we're going to talk about the Pythagorean Theorem. What the Pythagorean Theorem is it is a theorem that can be used to find the measures of different sides and shows the relationship between different sides of a right triangle. All right, so remember, a right triangle is a triangle that has one right angle. So you will know that it has a right angle because it will often be labeled with this box in the corner, and that indicates a 90-degree angle or your right angle. Okay, so we all know that there are three sides to the triangle. Two of those sides in a right triangle we call legs. Okay, the legs are the sides that are going to form the right angle. So when I look at my diagram, this is the right angle. This side right here and this side right here, they create that right angle. So those would be what we would call the legs of this triangle. The third side of the triangle is the hypotenuse. And the hypotenuse is going to be the side that's across or opposite the right angle. Okay, the hypotenuse also is the longest side of the triangle. All right, so just like when I had mentioned hypotenuse, what I do whenever I see a right triangle is I find that right angle and I draw a line going straight across from it, and the side that I go to, I label it hypotenuse. Okay, so right from the beginning, I know that's my hypotenuse, and the other two sides that are left are your legs. All right, once you have established what the three sides are, we then can use what we call the Pythagorean Theorem to solve for the different sides of different measures of the triangle. All right, so in a right triangle, it says that the sum of the squares of the lengths of the legs, so what that means, sum means I'm going to add together the squares of the legs. So in this case, when we label a right triangle, we label the legs A and B. So when I'm writing that formula, the sum of the squares, so A squared plus B squared, is equal to the square of the hypotenuse. And here's my 90-degree angle. So C is what we label the hypotenuse. Okay, so it equals the hypotenuse squared. This is your Pythagorean theorem formula. This is what you should memorize. Okay. It says the Pythagorean theorem describes the relationship between the lengths of the legs and the hypotenuse for any right triangle. And this only will work for right triangles. You can use the Pythagorean theorem to find the length of a side of a right triangle when you know the other two sides. And that's what we're going to do next. We're going to use this theorem to go through a couple of examples to find the missing side. All right. So I'm looking at number one, I'm given a right triangle, and I know this because right here is my right angle. So what I immediately do, since I have located the right angle, I draw a line across. The line that is across, the side that's across or opposite the right angle, I know this is my hypotenuse or my C. I'm then going to label the two remaining sides A and B. Okay, now that I have everything labeled, it's going to make it a lot easier to substitute into my formula. Okay, so since it's a right formula, I immediately think, okay, I'm looking for a missing side, Pythagorean theorem. I'm going to write that formula down. A squared plus B squared equals C squared. Formula. Now I'm going to substitute in what I know into the formula. Do I know my A value? Yes, it's 9. Do I know my B value? Yes, it's 12. Do I know C? No, that's what I'm looking for. So this is going to be your substitute line, okay? The next thing I'm going to do is I'm going to simplify and solve for my variable C. So 9 squared I know is 81. 12 squared I know is 144. And that will equal C squared, okay? All right, I'm going to pop in the calculator. 81 plus 144. And I get 225. So over here, 225 equals C squared. All right, then I need to still get C by itself. So I have to get rid of that squared. Remember, the opposite of squaring something is to take the square root. So that's what you're going to do on both sides. So now I'm going to put in my calculator, second square root, 225, 15, and I'm going to label it inches equals C. So right here, you're going to simplify, solve, and label. Okay, so we found that length of the side was 15. All right, let's look at number 2. So again, number 2, I look at this, and here's my right angle. The side that is directly across from it is C, my hypotenuse. The 2 remaining sides are going to be the legs, and this one is already labeled A, so I'll leave that A, and this is B. I'm going to use my formula. A squared plus B squared equals C squared. I'm going to plug in what I know. Do I know A? No. So I write A. Do I know B? Yes. 17 squared. Do I know C? Yes. 20 squared. Okay, the next step, I'm going to simplify what I can. Can't do anything to A squared. 17 squared is 289. 20 squared is 400. Okay, now remember, your goal is to get the variable alone. So in this case, I have to get rid of this plus 289 first. So just like equations in the beginning of the year, to get rid of a plus 289, I'm going to subtract 289 from both sides. So I'm left with A squared equals 400 minus 289 equals 111. I'm not done yet though, because I have A squared. I need to get A by itself. So remember, to get rid of that squared, you're going to do the opposite of squaring something, and that is to take the square root of both sides of your equation. So the square root of A squared is A, and then the square root of 111 is 10.5356, it keeps going. And the directions say to round to the nearest tenth. Okay, so since I'm rounding, I can say A is approximately, and when I round this to the nearest tenth, it will end up being 10.5, and then I'm going to label it centimeters. Okay, all right, let's look at another example, number 3. So here's my right angle. Again, the side that's across from it is going to be my C, my hypotenuse, and the 2 remaining sides are A and B. This one's labeled B already, so I'm going to label this one A. Okay, since I'm looking for a missing side of a right triangle, I'm going to write my formula. A squared plus B squared equals C squared. And now I'm going to plug in what I know. So A is 3. B is going to stay B, and I can put 8 in for C. I'm going to simplify what I know. So 3 squared is 9 plus B squared equals 8 squared is 64. Now this is just like the last one. My variable's over here, and that's what I'm trying to get alone. This is a positive 9, so to get rid of a positive 9, I'm going to subtract 9 from both sides. So on the left, I get b squared. On the right, 64 minus 9, I get 55. Now the opposite of squaring, I'm going to take the square root of both sides. So I can say b is approximately 7.4 miles. Okay. All right, so those are 3 examples where you are given a diagram and you are finding the missing side. You're using the Pythagorean Theorem, plugging in what you know, and then using algebra to solve for the missing piece or solve for the variable. Okay, and that will end up being the side that you're looking for. Okay, the next thing is we're going to go in the reverse direction. Okay, remember in the very beginning I said that the Pythagorean theorem will only work with right triangles. So we are going to go backwards. We're going to say that if we know the measures of 3 sides of a triangle, and if I were to plug in the measures of the 3 sides of the triangle, if a squared plus b squared equals c squared, if when I plug those 3 sides into the Pythagorean theorem, if it comes out true, if they do in fact equal each other, then I could say that that particular triangle is a right triangle. Okay? Pythagorean theorem will always be true. So we are going to use that fact to determine whether it is a right triangle or not. All right, let's look at an example. It says the measures of the 3 sides of a triangle are 6, 8, and 12. Determine whether the right triangle or whether the triangle is a right triangle. All right, so since I'm trying to determine if it's a right triangle, I'm going to think Pythagorean theorem. A squared plus c squared, well, a squared plus b squared, does that in fact equal c squared? Okay, now when I'm substituting in my values, there's one thing that you have to be careful of. Remember, c is your hypotenuse. And remember in a right triangle that the hypotenuse is the longest side. So regardless of the order of your measures, you have to find the longest side and make sure you're plugging that measure in for C. Okay, so I always look for that first. So here are my 3 sides, and I say 10 is the longest, so I'm going to plug that in for C. And then the 2 remaining sides, 6 and 8, I can plug in for A and B. Okay, so now I want to see, is this actually true? Does 6 squared plus 8 squared equal 10 squared? Well, 6 squared is 36, and 8 squared is 64, and 10 squared is 100. Well, if I add 36 and 10, I get 100. Well, since 100 equals 100, that means that a squared plus b squared does in fact equal c squared. So that means that this is a right triangle because it worked with the Pythagorean theorem. Okay, those measures ended up working out. So since 6 squared plus 8 squared equals 10 squared, this is a right triangle. Okay. Sometimes the 3 sides of your right triangle will be referred to as a Pythagorean triple. Okay, let's look at another example. I want to know 12, 7, and 9. Is this a Pythagorean triple or is this a right angle or a right triangle? All right, so I'm going to think Pythagorean theorem. A squared plus b squared, does that equal c squared? All right, I have 12, 7, and 9. Now remember, the longest measure, so in this case is 12, must go in for C. The 2 remaining sides, 7 and 9, are A and B. All right, 7 squared is 49. 9 squared is 81. 12 squared is 144. Well, when I add 49 and 81, I get 130. That does not equal 144. So I would say this is not a right triangle. It's not a Pythagorean triple. Since 7 squared plus 9 squared does not equal 12 squared, it is not a right triangle. Okay, look at another one. I have 10, the square root of 200, and then another 10. Okay, I could look at this because I need to figure out what is the longest side. Okay, so to determine what the longest side is, I can put the square root of 200 in my calculator, and that says 14. So that is going to be my longest side. So I'm going to substitute the square root of 200 in for C. That means 10 and 10 are A and B. 10 squared is 100 plus 10 squared is 100. The square root of 200 squared. Now remember, square root and squaring something are opposites of each other. So if I'm squaring the square root of 200, that kind of like cancels out that square root. It will equal 200. 100 plus 100 does equal 200. So I could say, since 10 squared plus 10 squared equals radical 200 squared, it is a right triangle. Okay. All right, let's look at another one. A squared plus B squared equals C squared. Plus 11.5 is my longest side, so I'm going to plug that in for C. So 7.6 and 8.4 are the other two sides. So I'm going to put it in my calculator. 7.6 squared is 57.76. 8.4 squared is 70.56. 11.5 squared is 132.25. All right, when I add 57.76 and 70.56, I get 128.32, which does not equal 132.25. So since 7.6 squared plus 8.4 squared does not equal 11.5 squared, it is not a right triangle. Okay, I'm going to skip number 5. All right, so to determine if something is a right triangle or not, plug in the side lengths for A, B, and C. And if A squared plus B squared equals C squared, it is a right triangle. If it does not, if A squared plus B squared does not equal C squared, it is not a right triangle. All right, last example. This is just where you are going to have to recognize, in this case, it says the hypotenuse of a right triangle is 15 yards. Hypotenuse is 15 yards. One of its legs is 11 yards. Find the length of the other leg. So I know in my formula, hypotenuse is always C. The one of its legs is A, and the other leg is missing. That's going to be the B. Okay, so now to solve it, I'm going to write my formula, and I'm going to plug in what I know. Do I know A? Yep, I said that was 12. Do I know B? No, that's the missing leg. Do I know C? Yep, that's the hypotenuse, which was 15. Okay, now I'm going to simplify this. 11 squared is 121. 15 squared is 225. And now I'm going to get B by itself. I'm going to do that by subtracting 121 from both sides. So I'm left with B squared equals 104. And then I have to get B by itself by doing the square root of both sides. So B will be approximately 1, 4. What does it say? Round to the nearest tenth. So this will round to 10.2 yards. Okay. And that's it. All right. I hope this is helpful. I did put a copy of these written out for you, so you wouldn't have to come back through the video if you wanted to look back at a particular example. So use your notes to help you get through. The homework for this is a Google, there's a worksheet, but I want you to put your answers on the Google form and submit that way. Okay, if you have any questions, shoot me an email. Thanks.